Hello students, welcome once again to Chem is Try. In this video, we'll be talking about qualitative analysis. Qualitative analysis is different from quantitative analysis. In quantitative analysis, for example, titration, quantity is of utmost importance to the chemist. However, in qualitative analysis, we are not interested in quantity, no. We are interested in what particular ion or what particular element or what particular substance is found in a sample that we have. Supposing we scoop a sample of garden soil and we think there are traces of copper metal inside. How do we ascertain the fact that truly traces of copper metal are inside the sample of soil? That is what we are going to talk about, qualitative analysis. So we are going to get a sample. Then we are going to test it to see what kind of substances are present in that sample that we have. We have inorganic qualitative analysis. And we have organic qualitative analysis. In the inorganic qualitative analysis, which we are going to talk about today, it deals with testing for the cations and the anions present in a sample. If we know the cations and the anions present in that sample, we can combine the cation and the anion to ascertain which compound is really present in our sample. In the organic qualitative analysis, which we are going to do in the future videos, we deal with what kind of functional group or what kind of class of organic compound is found in a sample that we have. Today, we'll be talking about how to test for cations. So supposing you have a sample, and we say there is an inorganic salt present in that sample. An inorganic salt, obviously, is made up of a cation and an anion. We are going to take about 7 cations. Then we'll talk about how to test for these cations. What we are going to use as our reagent, there is results that we expect to obtain after adding each of the reagents to our sample. So, with test for cations, there are things we need to look out for. First, we'll be using sodium hydroxide as one of our reagents and aqueous ammonia as our other reagent. And we will take our sample, then we will first add the sodium hydroxide and look out for the results. Now, what are we looking for in the results? Are we going to see a precipitate or not? If we see a precipitate, what is the color of the precipitate? What is the nature of the precipitate? Is it heavy, like chalky precipitate, or is it gelatinous? When we talk about gelatinous, it's just like when you put pieces of cotton wool into water, the way the pieces gently move in the water. Now, that is what we are calling gelatinous. Is that the kind of precipitate we are going to get? What if we add more of our reagent? Are the precipitate going to stay or they are going to dissolve? These are the things we are going to record as our observations during the test for cations. Now, let's delve into our first cation and see how the test is done. The first cation we have on our board is calcium. So, over here, this sample contains calcium ions. So what are we going to see if we add aqueous sodium hydroxide dropwise, then in excess? Are we going to see precipitates? What is going to be the color of the precipitate? What is going to be the nature of the precipitate? What if we add more of the sodium hydroxide? Is the precipitate going to stay or is going to dissolve? These are the things you are looking out for. So let's start. So let me pour a small sample of our calcium ions in this test tube. Okay? That's my sample. I take my reagent, then I add it dropwise. Do you see it? White, chalky precipitate. Now let me add the sodium hydroxide in excess and see what happens. Whether the precipitate will dissolve or not. So even after adding excess sodium hydroxide, my precipitate is insoluble. So how do I write this result? White, chalky precipitate, insoluble in excess. That is how I record my observation. Then I take the other small amount of my calcium sample. This time, I'm not going to use sodium hydroxide as my reagent. I'm going to use aqueous ammonia. That one too, I will add it dropwise, then later in excess. Few drops. I'm not seeing any precipitate. Let me add it in excess and see. In excess, I'm still not seeing any precipitate at all. So how would I record this one? Two ways. I could say no visible change or no visible reaction. Or I could write no precipitate formed. So no visible reaction, or I could choose to also write no precipitate formed. The PPT is the short form for precipitate. Please, when you write it, don't put a dot after the PPT. Just leave it like that. That is what we will get with calcium ions if we are to test with sodium hydroxide and aqueous ammonia. Well, we said no visible reaction. There probably might be a reaction going on, but the thing is, we cannot see the reaction. So if you write no reaction, that is wrong. No visible reaction. A reaction is going on, but we are not seeing any signs that shows that reactions is happening over there. Let's go to our second cation. Our second cation is zinc ion. Zinc ion. Well, I'll pour a small amount of the zinc ion into this test tube. Then, just as I did with the calcium ions, I'll add sodium hydroxide aqueous dropwise, then in excess. Few drops. Now, do you see the kind of precipitate we are forming? It's like cotton, pieces of cotton placed in water. Now, that is what I'm saying is called gelatinous precipitate. So, I formed a gelatinous precipitate. Let me continue adding the reagent in excess and see what happens, whether the precipitate will dissolve or it will still remain. Do you see the precipitate dissolving? Now, if it's not dissolving, shake it a little to see whether they will dissolve or not. So we formed white gelatinous precipitate. But this precipitate is soluble in excess sodium hydroxide. So how are we going to record this observation? White gelatinous precipitate soluble in excess. Soluble in excess sodium hydroxide. Soluble in excess to form a colorless solution. You realize that the solution is colorless. So you could add to form a colorless solution to your observation if you like. But you can still leave it as white gelatinous precipitate soluble in excess. Good. Let's move on to our second test, this time with aqueous ammonia. So I take small sample of the Zn2 plus ions. I take my aqueous ammonia. Then I add it dropwise. Another white gelatinous precipitate. Let me add my reagent in excess and see what happens, whether the precipitate will dissolve or it will persist. Precipitate has dissolved to form a clear solution. So let's record our observation. White gelatinous precipitate soluble in excess. Once again, you can add to form a colorless solution. So next, we continue with our Pb2 plus, lead 2 ion. We pour a small amount of our sample of Pb2 plus into our test tube. Then we add our aqueous sodium hydroxide dropwise and in excess. So first dropwise. We form a white chalky precipitate. Let's add our aqueous sodium hydroxide in excess and see what happens. Our white chalky precipitate dissolves, and we now have a colorless solution. So we would record our results. White chalky precipitate soluble in excess. We repeat this test, but this time with aqueous ammonia. So we add our aqueous ammonia to our Pb2 plus sample dropwise. We are forming white chalky precipitates. Let's do so in excess to see whether the precipitate will dissolve or not. In excess, our precipitate is not dissolving. So we write our results down. White chalky precipitate insoluble in excess. That is our result. Then we move on to aluminium. We take small sample of our aluminium. Then we add our aqueous sodium hydroxide dropwise. We are forming white gelatinous precipitate, just like the cotton particles that are found in water. Then let's try adding our sodium hydroxide in excess to see whether the precipitate will dissolve or not. What is happening to the precipitate? As you can see, it has dissolved. So we will put down our results. White gelatinous precipitate soluble in excess. Once again, you can add to form a colorless solution. Then we take another small sample of our aluminium. This time you will add aqueous ammonia, and we'll be adding it dropwise and in excess. So dropwise, we are forming gelatinous precipitate. Let's add it in excess and see what happens. Let's shake it to see if the precipitate will dissolve. You see the particles still inside? Insoluble in excess. So we have white gelatinous precipitate insoluble in excess. Now let's look critically at our table. With the test for calcium ions and lead-2 ions, using aqueous sodium hydroxide, we obtained white chalky precipitates. But in the case of calcium ions, that white chalky precipitate was insoluble in excess sodium hydroxide. But in Pb2+, it was soluble in excess sodium hydroxide. Do you see the difference between calcium ions and lead-2 ions? For their reaction with aqueous ammonia, for calcium ions, there was no visible reaction or no precipitate formed. But in the case of lead-2+, we formed white chalky precipitate, which was rather insoluble in excess aqueous ammonia. So there are two white chalky precipitates you are going to get. And you are going to get that from calcium ions and lead-2+ ions. And the difference is clear. Let's look at Zn2+ and Al3+. They are the two cations that give us white gelatinous precipitates. What is the difference? In Zn2+, we had white gelatinous precipitate, which was soluble in excess. The same thing that we had for aluminium. But the difference comes when you add aqueous ammonia dropwise and in excess. When you use aqueous ammonia dropwise and in excess on Zn2+, the white gelatinous precipitate formed becomes soluble in excess aqueous ammonia. However, in the case of Al3+, the white gelatinous precipitate became insoluble in excess. Now, do you see the difference between these two? So always to memorize, calcium ions and lead-2 ions, they both give white chalky precipitates. But there is a difference. Note the difference. Then Zn2+ and Al3+, they are not going to give you chalky precipitates, no. They are going to give you white gelatinous precipitates. And I've shown you how you are going to identify gelatinous precipitates. It looks like pieces of cotton floating in water gently. That is your gelatinous precipitate. And you are going to get that with Zn2 plus and Al3 plus. But there's a difference. And the difference is in when we add aqueous ammonia in excess. In Zn2 plus, it will dissolve. But in Al3 plus, it would not dissolve. In our next video, we'll be talking about another 4 cations. Their reactions with aqueous ammonia and aqueous sodium hydroxide, dropwise and in excess in both situations. So watch the next video. Thank you.